Hello and welcome to Top 10 Emerging Technologies, a show from the World Economic Forum that looks at the performance of some of the most promising technologies of the last decade. I'm your host, Greta Keenan, and in this episode, we'll be talking about self-healing materials, which made it onto our list in 2013. To get us started, let's have a look at this video from one of our events in 2016, where Professor Abir Al-Tabar from the University of Cambridge highlights the potential use of self-healing concrete.
Can we design our concrete structures to look after themselves? This way they could last so much longer, we would use far less concrete, slashing expenditure, carbon emissions and environmental damage. Looking to natural systems for inspiration, the concept of self-healing materials emerged. So can we turn the non-living concrete all around us into living systems? We see advances in other sectors, self-healing paint for our cars and self-healing roads, self-healing asphalt for our roads are becoming a reality. But concrete is a far more complex material. It is multi-component, multi-layered system, and damage occurs at different length and temporal scales.
Here today to tell us more about self-healing materials is Professor Abir Al-Tabar herself. Hi Abir, thanks for joining us.
Hi, thank you for having me.
So your research focuses specifically on self-healing cement, but taking a step back for a moment, could you tell us a bit more about self-healing materials generally? What are they and how are they used?
Self-healing materials are a group of materials that belong to what we call biomimetic materials. So these are materials that mimic nature and natural systems, which have the ability to sense their environment, adapt, response, and self-repair. So they have self-healing capabilities as well as self-sensing, self-diagnosing, and self-immunizing. And so the idea with using self-healing materials or biomimetic materials in general is to enable our materials to have a long and happy life. And so we are trying to mimic natural systems into our wide range of materials that we see around us. The other beauty about natural systems is that they're low carbon, low energy, and low waste. So we are building new materials with significantly enhanced sustainability and carbon footprint.
So self-healing materials were named one of our top 10 emerging technologies in 2013. How far has the technology come since then, would you say?
There's been development in multiple damage repair, so multiple components together, multiple materials together, looking at combining some of these attributes, so self-healing and self-sensing. And there's been obviously advances in nanotechnology and smart manufacturing and sustainability that we've been applying to the developments of those materials moving forward.
So what are the widespread implications of the type of work that you're doing on self-healing materials? Why are you interested in creating cement that can heal itself?
Yeah, the impact would be huge because cement has a large carbon footprint. And alongside the developments of quite a number of exciting low carbon cements, which minimize the capital carbon, we also need to minimize the service life carbon footprint. And so self-healing materials together with low carbon cementitious systems will provide this whole life carbon reduction. So we have sustainable products. We contribute significantly to reaching net zero by 2050.
I guess there's also an economic argument for creating infrastructure that's going to heal itself rather than having to keep repairing it year after year.
Absolutely. So you reduce the cost significantly. I think one issue to address now is, in most cases, the people who build are not the people who maintain. And so there is not much incentive for the constructor to worry about the repair and to install these self-healing materials from the beginning. So the idea would be to bring all these people together and to bring together sort of the responsibility of maintenance back to the client or to the constructor.
So looking ahead, possibly the next 5 to 10 years, where do you see this technology going?
Yeah, there are many exciting opportunities moving forward. So we're going to focus on roads, and we're going to basically transform our roads into biomimetic materials that can self-sense and self-heal. And they can communicate with the digital twins, they can communicate with robotics that will repair them. And we would like to combine that with even additional functionalities, because materials we embed in roads can also clean the air around the road surface, as well as alleviate flooding, as well as energy capture. And so there's many functionalities that we can add to the road materials that are at the moment passive.
What do you think is the timeline for these self-healing materials being completely integrated into our day-to-day life? It sounds as if the technology is still in its infancy, perhaps. So what is the sort of timescale for really widespread introduction to our societies?
I think a couple of things. Because the technology is so varied, I think some self-healing products will make it into the market pretty quickly. And we're focusing on those sort of low-hanging fruits, where actually the technologies or the type of technology, like the capsules, are already known in construction. More complex self-healing, which are so more intrusive, might require more delving into standards and actual impact on the performance of the structures.
Are there any barriers to self-healing materials becoming widespread in our societies and towns?
The barrier is always cost, and we are trying to minimize that as much as possible and make it compatible with the type of additives that are normally used in construction, and providing incentive for this capital investment at the beginning to provide longevity and sort of healthy life over the surface life of the structure. So construction is a very conservative sector. And so the use of any different mixes, additives in cementitious materials will require compliance with the standards.
Professor Abir Al-Tabar, thank you so much for joining us today and sharing all your insights on self-healing materials. Materials we use in everyday life, from car paint to concrete roads, have a limited lifespan. Self-healing materials offer a solution to this problem, with the potential to save time and money on material maintenance, as well as reduce the amount of waste and carbon emissions we produce. Although still in its infancy, the technology is advancing rapidly and could be used to repair buildings and roads in our cities in the years ahead. But if we want to integrate self-healing materials at scale, they will have to be affordable and regulated to meet construction material standards. If you enjoyed this episode, please join the conversation on social media, and we'll see you next time for another episode of Top 10 Emerging Technologies.